All right, this question tells us that we have a saturated solution of calcium hydroxide. So CaOH2, solid, saturated, so I have some solid at the bottom, but that which does dissolve does dissociate completely into 2OH minus and a Ca2 plus, both aqueous. So in the beginning I have some solid, and I don't have any ions that have dissolved and dissociated yet. So some dissolves. We don't have to write this each time, but this is an instructional video. Some dissolves, and that means that I get a corresponding change over here of plus 2s. Now that which dissolves is soluble, and that stoichiometric amount I'm writing as s moles per liter instead of x. You can write x. We're just writing s because we know that that will in the end be equivalent to the solubility of calcium hydroxide in solution. And this will just simply be a plus s. So that at equilibrium, when I have this saturated solution formed, I still have some solid remaining. But I have 2s and s in solution. Okay. Now, I don't have a KSP for this, and you don't have to go and look it up because I don't actually think we'll need it. This will be equal to the OH minus ion concentration squared times the calcium ion concentration, right? And that is equal to my 2s all squared times s. So usually when I do this kind of a question, people say, well, since you already have the 2s, why did you also have to square it? Remember, 2s is the concentration at equilibrium, and then the concentration at equilibrium is squared because of the stoichiometric 2, so it is 2s all squared. Okay, and so that tells us that our KSP is equal to not 3, but 4s squared times s, so that's 4s cubed. Now, if I knew what the KSP was, I would simply find my solubility by solving for s. In this question, I'm not given the KSP, but I am given the pH at equilibrium. Okay, so I do know that the pH at equilibrium is equal to 12.35. We expected it to be quite basic. And that tells me, therefore, that the pOH is this number taken away from 14. And that leaves me 1.65. So really, my OH minus concentration at equilibrium is equal to 10 to the minus 1.65. And that is equal to 2.2 times 10 to the minus 2 molar, right? Okay, so let's slide this up a bit. That's my OH minus concentration. And have I gone too far? Let's pull this back down just a little bit. Right there. In terms of solubility S, what is this equal to? Twice the solubility, 2s, is the concentration of OH minus. So if, therefore, 2s is equal to 2.2 times 10 to the minus 2 molar, okay, you see that? Then s, which is my solubility, must be half that, or 1.1 times 10 to the minus 2 molar. And so my solubility of calcium hydroxide under these conditions is 1.1 times 10 to the minus 2 moles per liter of solution. But they want us to determine how many milligrams are soluble in 100 mils of solution. Okay, well, if 1.1 times 10 to the minus 2 moles dissolve in 1 liter, then how many will dissolve in 100 mils? 10 times less, right? Okay, so 1.1 times 10 to the minus 3 moles of calcium hydroxide are actually dissolving in 100 mils, but they want milligrams. So let's convert this number of moles to milligrams. Now in 1 mole, I have 74.09 grams. Therefore, my answer is 81.5 milligrams.